to the 28th episode of our Space Shooter DevVenture and live stream sessions. Here we go. So remember I mentioned we were going to do our behavior system, the behavior management system, right? The behavior manager and the different behaviors of each enemy entity, and then the enemy manager as well, right? So there's 3 layers to this thing. There's the enemy controller, and then the enemy behavior manager, or the NPC behavior manager, and then we've got the third layer, which is the third layer down, going from top down. We were going enemy ship controller, then NPC behavior manager, and now at the bottom each behavior, right? So each behavior will fall under this thing called behavior type T, where type T is whatever the behavior is, right? So behavior underscore seek, behavior underscore patrol, behavior underscore shoot, behavior underscore flee, and so on. Okay, and now I need to go into the details, right? So I said, okay, now I want to start with so I said to DeepSeek, by the end of our last live stream, I want to use ordinary nodes for the NPC behavior manager and all behavior type T nodes, where type T represents the specific behavior name. Let's get started on the foundation of the NPC behavior manager script and class, please. Okay, we can begin by thinking about its adjacent layers and how it must interact with them. And then it went ahead and created these classes for us, remember? And we were going through them, but I found some problems with it. So ignore the code. We'll look at the code afterwards, but let's see the key design points and then check my corrections and then the corrected code, right? Because there's no point looking at code that has problems, except to learn from them, of course. But right now, I would rather just go straight to the correct code and explain the correct code to save time and to get actually going into the actual coding process. Okay, so here's the key design points. Again, this is what that misunderstanding, right? That there are some misunderstandings here that DeepSeek had that I corrected. So maybe I can correct those. So we'll go through these. We'll read the corrections and see if the corrections actually speak against some of these key points, because at the end of the corrected code, it will make new design points, right? So we can see the difference. Let's do this. So the key design points: upward communication to the enemy ship controller and downward communication towards the behavior nodes. Okay, so when a behavior is complete, then it sends that signal to the next layer when a behavior finishes. And if it was unable to finish and failed for whatever reason, it sends the behavior failed signal. And then we've got the ready for new pattern, which is a notification to say, okay, well, I'm ready for the next assignment, right? So give me and I'm guessing this is the NPC behavior manager that sends this signal, because it manages the patterns, right? And it's like, okay, well, I finished your pattern whatever. Let's say it was pattern 5. I finished pattern 5. Can you send me the next pattern? And then the enemy ship controller goes, oh, that's amazing. Here, do this pattern now. Or perhaps it's like, mission complete, and be on standby, for the next pattern. Then there's downward communication, like I mentioned, from the enemy ship controller towards the behavior nodes at the bottom, right? And that basically says, okay, well, activate. It calls activate on a behavior node with parameters. Okay, so this has to do with the NPC behavior manager class, okay, specifically, because we've already got the enemy ship controller. We just have to modify that. And we've got we don't actually have any of the behavior nodes yet, but it doesn't make sense to make a behavior node until we have the behavior node manager. Okay, and we've already got the seek behavior. We just have to put it into a node. right? So we have to put it in a node and code that node. So let's get to the corrections. Okay, so it calls activate to deactivate on those nodes, and then there's lateral communication as well. So discovers and manages child behavior nodes automatically and handles behavior transitions cleanly. This gives you a solid foundation that properly separates the tactical layer from both the strategic and operational layers. Okay. I think I had a drawing about the layers. Yes, here we go. Okay. So I had this, and we were busy with this around the time we ran out of time in our last session. Okay. So this here, go to cursor mode so you can actually see my pointing here. So the enemy ship controller is the strategic layer. Okay, so this is where it does all the high level analysis, scene analysis, as in who's where and who's doing what and why. Okay, and then what should they do, and are they doing it, and if not, why not, and all those things. That's the strategic layer. Then you've got the tactical layer, which is actually putting that strategy into action. Okay, it's one step above operational, which is the behavior, right? So the NPC behavior manager is not quite strategic, but it's not quite pure tactics either. Okay, and so it's more like taking those high level commands and figuring out how to get them solved. Okay, because the strategic instruction doesn't really care how it's done as long as it gets done. That's right. It's like saying, okay guys, we need to perform some kind of pincer attack, so flank them from the sides while engaging them from the front. So like I had with that other drawing, let me just get that drawing for you, open it. It was this one. Okay, so over here you see, let's say we had, for example, pattern 1. Okay, and this is a type of pincer attack because you've got these 3 enemies here engaging the target or the opponent, depending on how you look at this. If this was a mining ship, it would be a target or a victim rather than an opponent because it can't fight back, right? And so now you're engaging the target, because an enemy is also a target. I mean, really, it's just the target that fights back, right? So you've got these 3 enemies attacking from the front and keeping it preoccupied from the direct assault. And then you've got these other 2 coming from the sides, okay? And the enemy ship controller, which is the strategic layer, is not concerned with who does the flanking, as long as someone does the flanking, right? But in real life, that's not how, in pure strategy terms, it doesn't matter as long as someone does the flank on the left and someone does the flank on the right. Okay, which is why it's numbered rather than, numbering is specific, right? It's very specific. It's like saying, calling someone by their name, middle name, and family name all at once with their ID number or whatever as well. It's like, so that you are absolutely sure it's this guy, right? But if you're thinking in terms of separation of concerns, so forgetting pure strategy, because pure strategy is very specific. It's like, okay, yes, somebody does have to be the left pincer and somebody does have to be the right pincer, but who it is also important, right? Because you can't say enemy 2, you become the left pincer because you are 2 positions away from that, right? You're in the middle. You are the closest one to a direct assault, so you have to do the direct assault. But can you see now that this is positional and not ID based? In the example I've given you, that's based on location rather than identity. if enemy 0 happened to be in the location spatially, like in space, if it was in the position of enemy 2, then it would make more sense that you say, okay, well, enemy 0, you do the direct assault, and enemy 2, you become the left pincer because you're closest to that space. Okay, so there's also something like this to consider. And in terms of pure strategy, you can kind of see how they are both important, but at the same time, it's also what's more important is that the one doing the decision for strategic decision doesn't actually care who does the job, as in person, right? Identity. It's rather that whoever is the most appropriate choice for the job gets that job. Do you understand my point, right? My distinction. It's not that enemy 0 has to be the left wing no matter what. It's more that the enemy in position 0 has to do that left pincer, and the enemy in position 4 has to do the right pincer. Okay? I hope that's a clear difference that I've made, that you understand what I'm talking about. So that's the strategy, and it's not really concerned with who does what. It's just calling a pattern. It's saying, okay, guys, we need to do a direct pincer, right? So 3 out of the 5 of you have to be the frontal assault, and 2 of the 5 of you have to be the pincers, you know? And then, depending on who is where in space, you guys need to figure that out. Who's going to do what? Okay? So, in the NPC behavior manager, each NPC has their own behavior manager in their scene tree, right? Compositionally. And that decides from the pattern, right? Who is most appropriate for each position, right? For each of the roles. We'll call them roles. Okay, so each one has their role, ROLE, like a role that you play in a you know, in a scene. You know, an actor takes on a role in a script or in a play or in a movie, right? So the role they play in that pattern, right? They decide which role they play based on criteria which are stipulated in the pattern, right? Either inherently, so they either have some understanding from the beginning what each pattern is like and how to deal with it, or the pattern itself will give you parameters and they then take those parameters and handle it, right? And I'm guessing what would be more sensible is to handle this in a generic way, right? So that you don't have to preload hundreds, potentially hundreds of patterns, because we don't know how many patterns it's going to take to make dynamic, engaging, and less predictable gameplay. You don't want unpredictable gameplay, completely unpredictable, but you also don't want it to be too predictable, right? You want a balance in between that. At sometimes you can kind of understand how to deal with this enemy, that it's not just pure chaos, but at the same time you don't want it to be pure order as well, because then it becomes boring, right? Now, how do we deal with this in general terms? I don't know yet. Unfortunately, I haven't really done something this advanced yet. And so I am designing it and developing it as I go. So you'll just have to bear with me as I make some mistakes and learn from them. That is unfortunately the process of game development. A lot of the time you come across new problems that you've never faced before, and you just have to address them, right? It's not always the same problem in a different package. sometimes, a lot of the time it is, but then there are certain times where you'll face something you've never dealt with before, right? Especially if you're doing an indie game like I am, an independent game, which is not an established title. It's not, like a sequel to a game that's already already published, already successful, already has its design pattern and mechanics and everything set up, and you're just doing, a one-up or next iteration on that. If you're doing something new that you've never dealt with before, you're going to have to solve those problems, right? So let's go. If I go back to DeepSeek over here, okay, I made some corrections, if you remember, right? So there's the difference between strategy and operational, and then there's the tactical in between. So that's what I was trying to talk to you about, and then I got distracted by myself here. So strategy, tactics, operational. Okay. So this one says, okay, call a pattern. The NPC behavior manager says, okay, well, given the pattern and my location and the locations of my my fellow enemy NPCs, or not even enemy NPCs, my fellow NPCs, my allies, right? I'll take on this position because I'm the closest, or whatever, right? And then they will say, okay, well, given that I am in this, that I'm in this position, and this is the pattern, and this role is the role that I've chosen to fulfill, right, or the role that I chose to play, I'm going to call this behavior, whatever the behavior is, right? Seek, chase, flee, shoot, wander, patrol, whatever it is, doesn't matter, right? I'm going to call this specific behavior, and the behavior itself is the operational layer, right? So it's like, okay, well, if it's calling this behavior, then it's a literal set of instructions that are done verbatim, right? So it's like, do this, then this, then this, then this, then this, then this, and this, given some parameters. And if you can't, then let the next layer, or your superior layer, or your managing layer, let it know with some kind of message. I can't do this because of that. I can't seek my target anymore because I've been shot to pieces by the player, or whatever. So that kind of thing. And then I said here in my corrections that the signals you used here are incorrect by my understanding. The NPC behavior manager is not concerned with how behaviors are executed, and does not announce the completion of those behaviors either. The signals you should be defining are for the pattern and this enemy ship's role in that pattern. In the discover behaviors function, why not use a behavior of type T group to check if the child node is a behavior node? This will be more robust against nomenclature changes for the project's lifespan. Okay, so these are very specific corrections, and I suppose I will have to go into the code and show you. Okay, so here on the top, if I show you here, there are 3 signals, right? And if you look again, the class name is NPC behavior manager. All right. And the reason why I said that it shouldn't communicate that a behavior is completed here is because a behavior is the layer down from the NPC manager, and the behavior completed signal is a signal pointing upwards. So if I go back to Krita just to show you, all right, this layer currently, according to this mistaken code, is announcing to the enemy ship controller that a behavior is done, right? Where we actually want emit signal of task status to go up to the behavior manager, because perhaps a pattern calls for multiple behaviors in sequence, and we don't know that necessarily from or in general. We don't know that in general, but we know that there might be a specific case where a certain pattern requires the behavior manager to call multiple behaviors in a sequence before the pattern is done, right? And in that case, it shouldn't be letting the ship controller know that a behavior is done. It should be letting the NPC behavior manager know that the behavior is done. And then once the pattern, the full-on pattern is done, then you let the enemy ship controller know that the pattern is done. And then we move on from there, right? So that's the first mistake that I corrected. And the second correction here is down here. For child in get children for the discover behaviors, if the child, because again it's a behavior, right? If the child and the text behavior underscore is in the child.getScript.getResourcePath.getFile. So we're getting the file name and checking if it has in its file name the subtext behavior underscore. Okay, then we know that it's a behavior by the naming, right? Then we follow on with the body. Now that is viable, it will work as long as all of the behaviors are labeled in that way and they are named specifically with that prefix, right? Behavior underscore prefix. And it's not as robust as if we were just going to say, why not use a behaviors of type T group name or a behaviors name, right? Or a behavior node name or something. We use a group name and we make every single group node, every single behavior node a part of that group. And we check if this node, the child node, is of this group. Then we call the body. And that seems more robust to me. And so, yes, you're absolutely right on both points. Let me correct this. Okay. So, redoing the entire class from the start, okay, it's got an onReady variable called the enemy ship, which is a type enemy ship. And then we are referencing the enemy ship this manager controls. Excuse me. And then current active behavior pattern assigned by enemy ship controller. Okay. And we establish this as a string and we assign it an empty string because it doesn't have a behavior assigned right now. And it's better to just give it an empty string. Okay. And then the current active behavior node is of type node and it's also assigned a null, right? It's not got a node from the start because we don't want to start the scene and have it call some random behavior. We want it to have no behaviors. And until a behavior is assigned, it should be doing nothing. We can correct this, of course, if we give it an idle behavior. If there's an idle, IDLE, an idle behavior that we can establish as the default behavior, right? So it just hovers in space and doesn't do anything, or maybe it sits there in space and blinks the hazard lights or whatever, like we want to be, we want to be funny. We can reference the hazard lights of a vehicle, like on the road, and make it just flash its hazard lights to say, hey, I'm currently not doing anything. I'm just sitting here blinking my hazard lights. That would be cool. Just to prove, actually, that would be useful, not just cool. It would be useful because it lets me know that the behavior is actually working and that it's not just sitting there doing nothing, that it is actually doing nothing in the so-called right way. Because there's the right way to do nothing and then there's the wrong way to do nothing. The wrong way to do nothing is if it's actually got a null behavior, like null. Anyway, the available behaviors dictionary is all the behaviors it could call, right? So given that it's an enemy pirate and not a mining vessel, it can't dig, right? It can't dig, it can't do a prospector's ping, it can't do whatever else a mining vessel can do that is unique to mining vessel ships. Okay. And it can do stuff that are unique to a pirate vessel that other vessels can't do, right? And so that's where the available behaviors dictionary comes in. So we assign this dictionary, the curly braces represents a dictionary, right? And we give it an empty dictionary. And again, now in the ready function, we check what type the enemy ship is, right? So we can establish the available behaviors of the dictionary from a predefined list somewhere saved in our project, right? Like a JSON file or something. And only assign the available behaviors for the type of NPC, right? So given that it's a pirate, from all of the available behaviors that any ship could do in general, right? Only assign the ones that a pirate can do. And then we'll go through and check, okay, well, in the JSON file, each behavior would have actually no. You know what? that's that's a really interesting procedural way of doing things, right? Automatic and scriptable way of doing things. But the problem with that, of course, is complexity, right? And there's always the trade-off. And it's a complexity space problem. It's expensive in complexity and expensive in memory space, right? Space taken up on the machine. So instead of that, why not go through all of the child nodes, all the behavior nodes, right? And check what are these behavior nodes. And for each behavior node, we could get their behavior information and populate our dictionary that way. So for every behavior, for every node that's a child of this node, if it is part of the behaviors group, get its details and add it to the dictionary of available behaviors, right? That's not listed here. Actually, no, it is discovered behaviors. Never mind. So this is literally what it's doing. I was inventing this algorithm from scratch and I didn't even realize that that's exactly what it's doing. Oh man, that's really silly of me. Anyway, so in the ready function, we say that the enemy ship is get parent type as enemy ship. Type enemy ship. And then if there isn't one, so if the NPC behavior node, the NPC behavior manager node, has no parent, it's not assigned to an NPC ship. If it's not assigned to an NPC pirate, an NPC miner, an NPC defender, or whatever other NPC ships I decide to add to this game, right? Then it's got null. It's got a null reference error that it needs to handle. And so it pushes this error saying that the NPC behavior manager must be assigned or must be a child of an enemy ship. Okay? And then call return, and all return does is it cuts out of the ready, the ready function. It cuts out of the ready function early. So it doesn't call the rest of this. It just closes the function and moves on with whatever else is meant to happen. So this is an improper initialization step. If it's not assigned to an enemy ship, then it can't carry on, right? Because it's going to call enemy ship controller pattern assign connect and all of this stuff, and it's going to call discover behaviors and all of this. But why? Why bother with all of this if there isn't really any point to it? If you're not assigned to an enemy ship, you're not going to be able to move the enemy ship. You're not going to be able to control the enemy ship, so why bother? Okay. So if this passes, right? So, or rather, if this fails, because if it were passing, it would go in here. So if this fails, and there is actually an enemy ship this is assigned to, right? Then call all the discover behaviors code, and then connect the signals, right? So pattern assigned and pattern cancel, connect them, because these functions, enemy ship controller dot pattern assigned dot connect to the on pattern assigned function here, right, which is this one, and on pattern cancelled here, which is this one. So you can see that there's an on pattern assigned function, and then there's an execute pattern function that it calls, which is down here, and then there's an on pattern cancelled and a cancel current pattern, right? So this is all about, I can't remember the exact principle, but it's basically preventing unnecessary indentation. Okay. Now, the best practice is that you shouldn't be indenting this deeply. Okay. That this if statement here should be separated into a function, and this if statement here should also be separated into a function. And so you basically say for child in get children, call this function, and then in this function you would call this function, and then you'd have basically a straight line down like this, only one indentation, or at most two, like this, right? For now, we're not going to worry. That's another step called refactoring. Okay. And I know I'm going through a lot of detail in terms of like coding practices and all of these things, right? But it's important to know that these are best practices and you kind of do need to use them, because if you don't, then you're going to suffer later. Not now, but later. Okay? And especially if other people are working with you, then you have to be polite. Okay? And keep them in consideration, because they can't know the way you think. Not fully. Yes, they can come to know patterns of how you think, right? Oh, he thinks like this or he thinks like that, and he tends to do his algorithms in a certain way. But they don't know what you were thinking when you decided to do. Excuse me, I knocked the mic there. They don't know what you were thinking when you decided to do this or that, or make so many indentations or whatever, right? And it's also easier to read, right? Because look at this. This is a very deep indentation. Like, look how far in this goes, And just in terms of reading, it's easier to read this than this, Because now you go, okay, well, if there's an if statement, and then there's this body, and what happens if this fails? Oh, okay, now then we'll have to go here, and then you jump back out and you go down. And here it's even worse, because you're jumping in, and then you're jumping in, and then you're jumping in, and then you jump out and perhaps go down, or you jump out and jump out and jump out and jump down, right? And you can kind of see how jarring that might be for someone trying to understand this code. Okay. So as a best practice, you separate and refactor, right? So you could put this in a function, and you could put this in a function, and you could call this function from this function, and then call the upper function from this for loop. And then you've got a linear line, so for child and get children, call this function. And then in the body of this function, you call that function, and whatever. And maybe that might be overkill, but it's just an example, because this is a very small piece of code, relatively speaking. I mean, it is quite big, but relatively speaking, it's quite small. So anyway, for child in get children, If the child is in group behavior nodes, which is exactly what I recommended, then set the behavior type, which again up here was oh no, it's a new variable. We're declaring a new variable, right? So create a new variable called behavior type, assign its name with child.name.replace uppercase b behavior underscore with dot to lower, right? So make everything lowercase, and then set available behaviors at index behavior type with child. Okay, so for those of you who don't really know what a dictionary is, okay, it's literally a mapping. So if I were to show you this, okay, and just initialize my pin properly, set it to the main display, okay, and draw this out. While we have some time, we've basically got, how much time has passed? 36 minutes. Okay. So if we look at a dictionary in general, right? So let me just change the color to white so that it's easy to see the writing. And then if I say here at the bottom, just like this, I can say dictionary. I forgot that I'm trying to do single stroke characters. Dictionary. Okay, and then we'll just do a straight line for neatness sake, and then just correct this T to look nicer. Okay, so a dictionary does the following. Okay, it's got a key and a value pair, right? So a dictionary has a key. Well, let's color code it so that it's easier to see what I'm talking about. Okay, so complementary colors. We'll go with orange and, well, orange. Okay, so we'll say the key is the following, and then we've got a value, right? So we'll do bluish, like a lightish blue, and then value. Okay, and so now the value for a key, so you can kind of see that it's a mapping, right? We are mapping two things to each other. And so the key would be some string, right? And so in this case, it would be a behavior name. So we'll say like this, behavior underscore seek. Okay, and the value for behavior seek would be the seek node. So it would be seek dot scene. Scene. Okay, and that's one entry in the dictionary. So if I were to show you like this, remember that a dictionary has curly brackets. Okay, and each entry is separated by I think it's a comma, if I'm not mistaken. It's this one. it doesn't matter too much. The point is that we are trying to just show that, okay, so then we've got the key and the value, and then we can draw another separation like this. Okay. And then we can switch over to another color, so key, pen, key, that's a very bad looking B. Behavior underscore shoot. Okay, and then the value would be shoot dot scene. And so on, okay? And let's say it's just those two behaviors, then we close the dictionary. So I hope that makes sense, okay? So a dictionary is a mapping between key and value, right? So when I want to call one, I could say, let's say I wanted to get the seek.scene value from the dictionary, I would have to call by key, right? So I would say in white ink, okay, I would say dictionary in position behavior seek, right? Behavior underscore seek, close the bracket, and then that would return a string. I mean, it would return seek.scene, right? So that would give me seek.scene, cn. So irritating when you make mistakes like that. Okay. Not really irritating, but it is just an inconvenient thing to have to correct your mistakes when you're trying to explain something. Anyway, so what I can do with that is assign it or call it or do something, right? So I could say, so I'm going to abbreviate this, right? I'm going to abbreviate it to D T N Y, right? Dictionary. Or maybe not. We'll just use D N R Y, like deanery. Okay, so it's easier for me, it takes up less space, it goes a little faster to explain. Okay, so now I could say dictionary in position behavior underscore seek, right? That will basically give me this node. And now what I can do is say call dot dot seek, right? And so now what this does is it actually gets the seek function from the seek scene, right? So this part switch back to cursor. This part gets me seek.scene, and this part gets me the function from seek_scene, right? So that is how dictionaries are helpful and useful and how they work. Okay, now let's get back to the code and try and get through this. Okay, so that's what we are doing here. We are creating that connection. Okay, so attach seek.scene, seek.tscn, attach it to the key. Right, so set the value of this key to be the child node. Okay, and then if the child has a signal behavior completed, then connect it with on behavior completed. Okay, in the node itself. No, on behavior completed is here. Yeah, right. So once the child has let the behavior manager has informed the behavior manager that its behavior is done, we need to give it another behavior, right? And so and also let we should add another status here eventually, right? To say that maybe it's not finished with the pattern yet. Maybe the pattern requires it to perform a string of behaviors. But we'll get to that. We'll get to that, right? Excuse me. So ignoring that for a second, on behavior completed connected to this signal, right? So the child has a signal, or if it does have this signal, behavior completed, then connected to that function I just showed you. Okay, then we've got this other pattern here, which we called, we tried to connect to over here, right? On pattern assigned, which takes in an enemy ship ID of type integer, a pattern of type string, and the parameters as a dictionary. Okay, and then if the enemy ship ID is the same as the enemy ship.id, right? So enemy ship, remember enemy ship on top here, this enemy ship is the calling, like the parent node of the manager, right? So this ship, whatever this ship is. So if it's a pirate ship, if it's a mining vessel ship, whatever it is, if the enemy ship ID matches my ID, right? So let's read it from the perspective of the pirate ship, because we're trying to control a pirate ship in this example. Okay, so as the pirate ship in my on pattern assigned function, I'm checking if this parameter matches my ID, and if it does, then I execute the pattern, whatever the pattern is, with those parameters. Okay, and so the execute pattern function tries to do a match on the pattern and all of that kind of stuff. Okay, but for now we don't worry about this. We'll just carry on with this, right? So we're done here. Then we move on to this one, right? So on pattern cancelled. So if for whatever reason the enemy ship controller decides to cancel a pattern, maybe it's trying to switch to a different pattern, right? Maybe it was calling pattern 5 and then things changed and pattern 5 was no longer feasible or effective or wise, whatever, right? Maybe a better pattern to call after the change in the scenario would be to change to pattern 7, but pattern 5 is not done yet. Then we call pattern cancelled, right? So we cancel the pattern and then we call the next pattern, right? So, hey guys, I know you're busy with pattern 5, just stop whatever you're doing and do pattern 7 instead, right? I hope that example makes sense to you. Okay, so on pattern cancelled goes with enemy ship ID. Okay, And then if the enemy ship ID matches again, so we're talking from the first person here. So if the enemy ship ID parameter matches my ID, then we cancel the current pattern. Okay? And then cancel current pattern has its own function, which is down here, and we'll get there. Okay, we'll get there. So before we continue with everything else, we'll just do a quick reminder that this function here is being called in this case, right? So if there was a pattern assigned and the enemy ship ID matches my ID, then I call execute pattern with the parameter string and the dictionary of parameters, right? The pattern string and the parameters dictionary. So here we go. We take in the string called pattern, and we take in the parameters as a dictionary. Okay, and then if any current pattern is running, so again, if I'm running pattern 5 and the enemy ship controller decides to tell me to do pattern 7, I need to stop pattern 5, and so I call cancel current pattern. Okay, and then I assign my new I reassign current pattern to be this new pattern, right? So if I was doing pattern 5, I call cancel current pattern on pattern 5, and that will likely set up my current pattern to be an empty string again, and then I reassign current pattern with the given parameter, which is the pattern of type string. Okay, I hope that makes sense. I mean, it should make sense. And you can always let me know in the comments if it doesn't make sense. And if it's still during the live stream, I can correct myself or clarify things for you. And if it's after the live stream, then either I can correct myself in the comments below yours, or someone else can. And yeah, so then we can move on. Right, so now we've set up the pattern with the parameter that was passed in, and now we can call match on the pattern. Okay, and if the pattern is patrol, then we can call activate behavior seek parameters. Same thing for attack, same thing for flee, and so on, right? And it's using some examples as placeholders, and we can always just change that. Okay, and then this underscore colon here is the default. Okay, the default for match. So if there was no match, then that one will apply, the underscore. So this is the so-called elf. Sorry, not elf. You've got an if statement, you've got an elif statement, which is else if, and then you've got the else statement, right, for the if statement blocks. For a match block, your else is this underscore. So if my pattern couldn't be matched to any of the given cases that I've provided, then we have a generic case that defaults in that situation. And we push an error saying unknown pattern, and we say whatever the pattern was, right? Because it's of type string, we concatenate it. Concatenate just means add two strings together, right? We concatenate the string called pattern to this, sorry, I'm pointing with my finger. We concatenate pattern to unknown pattern, and so it'll say unknown pattern colon space, whatever the pattern is, right? And then emit a signal, pattern failed, right? Pattern failed dot emit, and then give the enemy ship ID, the pattern, and the message unknown pattern, right? That's the reason. So it's saying who is emitting the signal? Saying the pattern failed, right? So who said pattern failed? What was the pattern that failed? And why did the pattern fail, right? And then activate behavior, you can see it over here. We are defining it over there. Okay, so activate behavior takes in a behavior type of type string and the parameters as a dictionary. And then if the available behaviors dictionary has behavior type, right? So if behavior type is in the dictionary, then current behavior is assigned available behaviors at behavior type. So we are getting, again, so we're getting the value for this key. Okay. And then assigning it to current behavior. So we were likely just assigning a child node to current behavior, right? And then we call current behavior.activate enemyship.id with parameters. So that means that every single node will have to have some kind of activate method. I hope that's clear to you, right? Because we haven't defined a behavior node yet. Any behavior nodes. So we're going to need to have some type of activation function, right? That takes in the enemyship ID and some parameters. And depending on the node, it's going to need those parameters, right? So the seek node is going to have its own set of parameters. And the shoot node is going to need its own parameters, if any. Again, if any, right? And so you've got all of these things that you need to consider when it comes to, like, a lot of people say coding, but this isn't coding. This is actually programming, right? And there's a difference, and the difference is strategy versus tactics. Same thing, right? So programming is strategy, high level design between large components, system-wide design, architecture. This kind of stuff is programming. And then coding is the logistics and the tactics and actually writing the code, the scripts, right? But well before you write any lines of code, you should be programming, which is what we were doing, right? We were designing the layers and the architecture and all of that stuff. So that's the programming, and this is the coding. So that's the distinction. Now, when if the behavior was available, right? So available behaviors.has behavior type and all of that stuff. If it isn't available, then we push an error, behavior not available, and the behavior type, because it's, again, just a string. So we concatenate that onto this and say, let's say we are a pirate, and for whatever reason, we are trying to activate the behavior for dig or for the grinder, to dig, right? Then it would say behavior not available, dig, or behavior not available, prospectus ping, right? And emit the pattern. So pattern failed dot emit. Who failed to emit? Who failed the pattern? Which pattern failed and why? Okay, and then function cancel current pattern. So if the current behavior exists, right? So if it's not null, and the current behavior has a method for deactivate, right? So if there's a deactivate function in the current behavior and the current behavior is not null, then call that deactivate function. And if the current pattern is not an empty string, then pattern interrupted dot emit enemy ship and current pattern. So emit the signal, the pattern emitted, the pattern was interrupted. So emit that signal of pattern interrupted with who emitted the signal and which pattern, right? And then the current behavior is set to null and the current pattern is set to empty string. So like I said before, right? It should have been set to empty string, and it was. We confirmed that. So here, current pattern is set to a new pattern after being cancelled. And if we look back down here, current pattern was set to an empty string. So I was right. Okay. Then function on behavior completed. Who completed it? What did they complete? What is the status? And is there any data, right? So the enemy ship's ID as an integer, the behavior type as a string, and the status also as a string, and then the data as a dictionary. Okay? So then we match status, which is a string, remember? If the status is completed, then we call pattern, we emit the signal pattern completed. Who completed the pattern? What was the pattern? And what is the status? Success, right? And then if the status was failed, then we emit the signal for a failed pattern. So pattern failed dot emit. Who emitted the signal? Which pattern was failed? And is there any data? Right? Reason unknown. And then ready for the next pattern. So we emit the signal for like we are ready for a new pattern, and then we emit that signal with who, right? So who's ready for new pattern, and then current behavior set to null, current pattern set to null. And then in the process function, this is optional. We don't need that right now, but we'll put the placeholder for it anyway, right? So here's the key corrections. We've now got the correct signals: pattern complete, pattern failed, pattern interrupted, ready for pattern. And so now all of these patterns, as you've seen here, were initialized, and we've got the various methods available, functions, we've got them available for use regarding these patterns. We can emit them, we can connect them, we can call functions regarding them and connect them to them and all of that stuff. Okay, and then it's also a robust behavior discovery. So we're using behavior nodes, the group tag behavior nodes instead of a file name. And this is robust against any type of change in nomenclature that I decide to use, or if I was working in a group that someone in the group decided to switch the nomenclature of all the behavior nodes or some of the behavior nodes, or maybe he wasn't aware that there is a specific nomenclature for behavior nodes. And again, I remind you that nomenclature is just a synonym for, or just a term that people use for naming convention, right? So if the naming convention was uppercase B behavior underscore, right? Behavior with an uppercase B, and this guy wasn't aware that it was an uppercase B and they decided to use a lowercase b, or they omit that prefix entirely and just name it seek. You know, they just add seek to the node. This is robust against that, right? And as long as it's part of the behaviors or the behavior nodes group, it will find that node and add it to the list of available behaviors. So that's amazing. Okay, so it uses this as a group instead of checking the file names, and it's much more maintainable and flexible, and again robust, right? And then the manager now properly focuses on pattern level concerns without getting involved in behavior implementation details. Okay, now we have officially run out of time, but I really did want to take this entire session to teach and explain, right? What and also just to go through all the code and make sure everything is right this time. That DeepSeek has done its job. I need to confirm that it's done its job correctly, and also to explain how the behavior manager is doing what it should do, right? How the code is actually operating and all of those things. So I hope you enjoyed this live stream and you found it insightful and helpful. And I'm going to conclude this by making a shout out to Cubes. Thank you very much for your support. He is our junior DevVenturer. And to the rest of you, you are welcome to visit coffee.com/mtkdev and support the channel. And if if you don't want to give a donation or become a junior, a DevVenturer, a member of the channel, right? If you don't want to become a member, you're welcome to support in other ways, like share this this live stream with other people, or just to like it, just give it a like, and then also, of course, subscribe to the channel, right? And all of these things are ways of letting YouTube know that my videos are popular, and it will continue to promote my live streams to other people. And you don't have to do a thing for that, right? All you have to do is like the video and share the link, and also just subscribe, of course. So with all of that being said, thank you so much